Hello everyone, good evening. This is lecture number 17 of ODE. So where we are solving problems based on second and higher order linear differential equations with constant coefficients, right? So from lecture number 1 to lecture number 13, we have been solving problems based on solutions of differential equations of first order and first degree, right? There are many methods to solve differential equations of first order and first degree. So we have finished all those methods from lecture number 1 to lecture number 13. In 14, 15, 16, that is in the previous three videos, we have been solving problems based on second and higher order linear differential equations, constant coefficients, right? Okay, super. So we have classified them into type 0, type 1, type 2, right? And type 3. Type 0 is RHS is 0 and type 1 is RHS is e power x, type 2 is RHS is sin x or cos x, and type 3 is RHS is of the form a polynomial in x, right? So in the previous class we have solved two problems based on type 3. So we'll continue solving problems based on type 3. We will try to finish type 4 and type 5 also in this class, right? Okay, so we'll get back into a problem. So this is a continuation of previous class, right? So I strongly recommend you to watch all the previous videos before watching this video, right? In the 16th lecture, we have solved two problems based on type 3, right? That is RHS is of the form, that is RHS is a polynomial in x, right? So we will start with third problem now. In the previous class, we have solved two problems on type 3. Now we'll start with third problem now, right? Super. Okay. Is any doubt up to now or we'll start, right? So we'll start. So solve this third problem now we are doing. Systematic. Yes. So solve d cube by dx cube minus 13 dy by dx. Double the writing. Okay. So minus 13 times dy by dx plus 12y is equal to x, right? Now you can see it is a linear differential equations of constant coefficient, right? It is of third order. So what is the general format of linear differential equation? So dn by dxn minus 1 plus dn minus 1 by, you know, right? Okay. So we'll solve this. So and you can see RHS is a polynomial in x. So it is x here, which is a polynomial of degree 1, which is x. So we'll solve this now. Okay. So first, the general solution is given by. So I'll do a little bit fast, right? Because if you have seen previous videos, then all problems will be very easy for you, right? So I'll do a little bit fast. General solution is given by y is equal to characteristic function plus particular integral. So first we will find a CF. So to find CF, right? So given equation is like d cube minus 13d plus 12 of y is equal to x, right? So to find CF, we will find auxiliary equation. So which is m cube minus 13m plus 12 is equal to 0, right? M cube plus 13m plus 12 is equal to 0. Now clearly you can see 1 is 1 root, right? Because 1 minus 13 is minus 12. Minus 12 plus 12 is 0. So that means 1 is 1 root. So we will find other roots. So the coefficients are m cube is 1. There is no m square term. And the m quotient is minus 13. Constant term is 12, right? We'll add 0. So 1 plus 0 is 1. 1 into 1 is 1. 0 plus 1 is 1. 1 into 1 is 1. Minus 13 plus 1 is minus 12. 1 into minus 12 is minus 12. So we will have 0 here, right? Therefore, the other two roots are, right? So clearly m is equal to 1 is 1 root. The other two roots are the solution of x square plus x minus 12 is equal to 0, right? This is the quotient of x square term, this x term, this constant term. We'll solve this equation. So okay, we will write m square instead of x square. because it is in m, right? So this will be m square plus m minus 12. So other two roots are minus 1 plus or minus root of b square minus 4 times ac divided by 2 times a. So it is minus 1 plus or minus, this will be root 49, which is 7. So 7 by 2. So minus 7 plus 1. So it will be 6 by 2. So 6 by 2 is 3. Minus 1 minus 7 is minus 8. Minus 8 by 2 is minus 4, right? So therefore the roots are 1, 3 and minus 4, and all are distinct, right? All are real and distinct. All are real and distinct. Therefore, our characteristic function is c1 e power m1x plus c2 e power m2x, c3 e power m3x. This is a characteristic function if your roots are real and distinct. So it will be c1 e power x plus c2 e power 3x plus c3 e power minus 4x, right? Yes. Now we will find partial integral. It will be 1 divided by d cube minus 13d plus 12 of x, right? So 1 by f of d into RHS. So 1 by f of d is this function, d cube minus 13d plus 12 into x. Now you have to take the, you just see this as a polynomial of degree 3. So which is the least degree here? Constant term is the least degree. So you take the term outside. So we take 12 outside. This will be 1, and this will be d cube minus 13d divided by 12 of x, right? So this is same as 1 by 12, 1 plus d cube minus 13d by 12 whole power minus 1 of x, right? So 1 plus x whole power minus 1. So 1 plus x whole power minus 1 is 1 minus x plus x square and so on, right? And so on into x, right? So 1 plus x whole power minus 1 is 1 minus x plus x square minus x cube and so on. So we will have, so we will simplify this. So 1 by 12. Now we can see d of, if first derivative of x is 1, right? Second derivative is, it will be 0. So from d square, d cube, d power 4, everything will be 0, right? So we will have only what? D term only. So d of x is, differentiation of x is 1. D square of x means we have to differentiate x twice. In that case, it will be 0, right? So d square is 0 means d cube is 0 and so on, everything is 0. So we will consider only d term, d square, d cube, all of the term will be 0, right? So we will have this term to be equal to 1 minus d cube by 12 plus 13d by 12, right? I'm just bringing this minus inside. And here you can see a square will be d power 6. B square is d something, 169 d square. 2 times AB, which will be d power 4. So every term here is of order d, it is of order d square and more. But we know order of d square itself is 0. That means this term, this entire term will be 0, right? All of the remaining terms will be 0. Because this term is at 0. The next term will be cubing that term. If you cubic the term, then all the terms will be of degree what? Every term will be of degree greater than or equal to 2 only, right? So in that case, every term will be 0 out. And this is also 0, right? Because d cube of x is 0. Because d of x is only 1. D square of x is 0. So we will have only 1 by 12. So multiply x inside. So x minus 13 by 12 d of x. That's it, right? 13 by 12 d of x. Okay, so that means d of x is, derivative of x is 1. So we will have 1 minus 13 by 12. 1 minus 13 by 12. So this is your required, this is plus. So 1 plus x by x 1 by 12 x plus 13 by 12 is your partial integral. So therefore the general solution is y is equal to cf plus pi, and c1 is e power 1x plus c2 e power 3x plus c3 e power minus 4x plus partial integral, which is 1 by 12 x plus 13 by 12. This is your general solution, right? Super. Now we'll start solving fourth problem. Fourth problem is solve d cube by dx cube plus 3 times d square y by dx square plus 2 times dy by dx. So we'll try to complete this entire topic by today. It's equal to x square, right? I'm going to do a lot of problem. So we will do fast. So the given equation is same as d cube plus 3d square plus 2d, right, is equal to x square. This is the given equation, right? So d is d by dx, 2d of y, 2d of y. Because we know capital D is d by dx. 2d of y is equal to x square. So it is a linear means for degree is 1. Even though order is 3, degree is 1 only for all. So it is a linear differential equations with constant coefficients, right? 3, 2, 1, all are constant. And it is of the order 3, right? And RHS is polynomial in X, so it comes under type 3. So we will find what is general solution. The general solution is given by y is equal to CF plus PI, right? CF plus PI. So now first we will find CF. So to find CF, so it is given by the roots of m cube plus 3m square plus 2m is equal to 0, right? So if I take m common, we will have m square plus 3m plus 2 is equal to 0. So m is equal to 0, or that is m is equal to 0 is one root, or m square plus 3m plus 12 is equal to 0. Now solve this equation. You will have the roots to be equal to so solve this equation, right? So m is equal to minus b plus or minus root of b square minus 4 times ac divided by 2 times a d cube d square minus b plus or b square minus 4 times a divided by 2 times a. This will be 48 d cube by dx square plus 3 times d square by dx square plus 2 times dy by dx equal to x square. M square plus 3m plus 2. So minus b plus b square minus 4 times a plus 2 times a. 48. Okay, I think there is some problem in the question. Just a minute. Just a minute. Let's check the question once again. F square plus 3 times d square by dx square. Just check the question once again. Just a minute. Okay, sorry. 2, right, sorry, yes. It's 2. That's only, actually, you'll be getting some nice answer only in this year, right? That's only I have confusion that the question is wrong. Okay, sorry. It will be minus 3 plus or minus 9 minus 8 is 1, so 1 by 2. So, thank you, Kennedy. So minus 3 plus 1 is minus 2 by 2, which is minus 1. Minus 3 minus 1 is minus 4. So minus 4 by 2 is minus 2. Therefore, the roots are 0, minus 1, minus 2, which are real and distinct. Therefore, your CF will be C1 e power first root into x, C2 e power m2x, C3 e power m3x. This is your characteristic function. Now, we will find partial integral. To find Pi, so Pi is 1 divided by, the question is d cube plus 3 times d square plus 2 times d of x square, right? So what is the least degree here? 2d is the least, right? So as of now, you think it's polynomial. Actually, it is a differential equation, right? As of now, just to give you a, I'm just giving you some hint, right? Some shortcut that you always say the least order outside. So we take least order outside. So 2d is the least order. So it will be 1 plus d cube plus 3d square by 2d, right, by 2d of x square. Okay, so this will be, this is same as 1 by 2d. If we take this out, if I bring this to numerator, we will have 1 plus d cube plus 3d square by 2d whole power minus 1 into x square, right, into x square. Now we will use the formula 1 plus x whole power minus 1. It will be 1 by 2d. Remember, we have 1 by 2d outside. That means what? Whatever the term here, we have to integrate that because we have 1 by d, right? So 1 plus x whole power minus 1. So it will be 1 minus x, 1 minus x plus x square d cube plus 3d square by 2d whole square and so on up to x square, right? So we have x square. So d of x will be 2x, d square will be 2, d cube will be 0, right? Constant of derivative is 0. So from d cube everything will be 0. You have to consider up to d square, right? So this will be 1 by 2d, 1 minus, so we will do this separately here. So it will be d cube by 2d minus 3d square by 2d. And here, if I expand this, right? If I expand this, a square plus b square plus 2 times ab, everything will be of order greater than or equal to 4. Yes or no? Yes or no? So here you can see d cube plus 3d whole square by 2d, right? Okay, we have 2d square here, right? Okay, what we will do is, okay, we will expand this. So if a cube, right? So sorry, a plus b whole square should be a square plus 2 times a into b. A into b will be d power 5, right? D power 5 plus 9 d power 4. Yes or no? A square plus 2 times a into b plus b square divided by, it will be 4d square, 4d square and so on into x square. Again you can see d power 6 by 4d square, d power 6 by 4d square. It will be d power 4, which is 0. It will be d cube here, which is 0. Here we have d, here we have what? If I do separately, here you will have some 9d square, right? This will be 0, this will be 0. If you divide here, you will have 9d power 4 by 4d square. So which is, let us write it here. So 1 by 2d, let us multiply this x square inside. X square minus, and cancel this 1d. So we will have 1 by d, d square of x square minus 3 by 2 d of x square. And here d power 6 of x square will be 0, right? D power 5 will, remember you have to divide and then multiply. So you will have d power 4 here. D power 4 of x square is 0. D cube of x square is again 0. And here we will have 9 by 4 d square of x square, right? Yes. So here next all term will be 0. So this will be 1 by 2d x square minus 1 by 2. So d square of x square 2 times it is 2 minus 3 by 2, again 2 times of x square, right? 3 by 2, sorry, d of x square is 2x plus 9 by 4 d square of x square is 2, right? First derivative is 2x, second derivative is 2. So this will be 1 by 2d x square minus 1 minus 3 into x is 3x. This will be 2, right? 9 by 2. So this will be 1 by 2d x square minus 3x minus 1 plus 9 by 2. So minus 2 plus 9. Minus 2 plus 9 is plus 7 by 2, right? Now this is same as 1 by 2. 1 by d of this is what? Integral of x square minus 3x x square minus 3x plus 7 by 2 dx, right? This is what 1 by d means integrate. So this will be 1 by 2 x square dx is x cube by 3 minus 3 times 3 times x dx is x square by 2 plus 7x by 2. Here we don't need to take any constant, right? I'll tell you the theory. Okay. So 1 by 2, this will be x cube by 3 minus 3x square by 2 plus 7x by 2. This is your partial integral. So therefore, general solution is CF plus PI. So add it up CF and PI to get the answer. Okay. So we'll move on to fifth problem. Solve d cube by dx cube minus 3 times d square by dx square minus 6 times dy by dx plus 8y is equal to x plus 8y is equal to x. I'll do it fast. This is same as d cube minus 3d square minus 6d plus 8 of y is equal to x, right? So we will find characteristic function. So we have m cube minus 3m square minus 6m plus 8 is equal to 0. And you can see 1 is 1 root, right? 1 minus 3 is minus 2. 8 minus 6 is plus 2, which will be 1 is 1 root. So this will be 1 minus 3 minus 6 and 8. So we will have 0. 1 plus 0 is 1. 1 into 1 is 1. Minus 3 plus 1 is minus 2. This will be minus 2. This will be minus 8. This will be minus 8. This will be 0. So other roots are the solutions of m square minus 2m minus 8 is equal to 0. To solve this, we will have minus 2 plus or minus root of b square minus 4ac divided by 2 times a. So we will have 2 plus or minus, this will be 4 plus 32, which is 36. So we will have 2 plus or minus 6 by 2. So 2 plus 6 by 2 is 8 by 2. 8 by 2 is 4. 2 minus 6 by 2 is minus 4 by 2, which is minus 2. Again, you can see the roots are real and distinct. The roots are 1, minus 2 and 4. 1 minus 2 and 4. Therefore, our CF will be C1 e power 1x, C2 e power minus 2x, C3 e power 4x. So now find PI. We will find partial integral. So PI is equal to 1 divided by d cube minus 3d square minus 6d plus 8 of x. So we'll take 8 outside. So we'll have 1 plus d cube minus 5d square minus 6d divided by. Sarah, have we ever browsed whether why we are not taking a plus c here? See, you asked in the question in the previous class. Have we ever browsed in internet why we are not taking a plus c here? So 1 by 8, this will be 1 plus x. It is very simple only. D cube minus 5d square minus 6d divided by 8 whole power minus 1 into x, right? So 1 plus x whole power minus 1 into x. So this will be 1 by 8. So 1 plus x whole power minus 1 will be 1 minus x d cube minus 5d square is 3d square. Is 3d square. D cube minus 3d square minus 6d 1 plus x 1 minus x plus x square whole square and so on into x, right? So 1 plus x whole power minus 1. So this will be 1 by 8. So 1 minus d cube by 8 plus 3d square by 8 plus 6d by 8. And here you can see here we have x. So d of d will be 1. So d square and every term will be 0. So here you can see every term will be of order d square and more, right? A square is a plus b plus c whole square, a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So every term will be of the order greater than 2 only or equal to 2, right? So a square, b square, c square all will be degree greater than 2, a, b, b, c, ca. So that means we can omit all the terms after this. So this will be again d cube is also 0, d square is also 0, right? So we will have this to be 1 by 8. So multiply x inside. So x plus 6 by 8 d of x. D of x is 1. So we have 1 by 8 x plus 6 by 8. So this is your required answer, or 1 by 8 x plus 3 by 4. Cancel with the two tables, right? This is a required pi. So therefore, the general solution is y is equal to CF plus pi, right? So just add it up both. 160 problem. Solve d square y by dx square minus 4 times dy by dx plus 4 times y is equal to x square plus e power x plus cos 2x. See, you can do what I'm going to do is, okay, let's do this. So we have d square minus 4d plus 4 of y is equal to x square plus e power x plus cos 2x, right? The general solution is given by y is equal to CF. You can take all to be pi, right? All to be equal to RHS of pi, and you can do in type 4. But what I'm going to do is I'm going to split. I'm going to do x square by, I'm going to call this as pi1, pi2 plus pi3. So for pi1, I'm going to make use of type 3. For pi2, I'm going to make use of type 1. And for pi3, I'm going to make use of type 2, right? Okay, so we will do one by one. So to find CF, the auxiliary equation is m square minus 4m plus 4 is equal to 0. To find the roots, you will have two are the roots. Therefore, your characteristic function is c1 plus c2x e power 2x, right? Now I'm going to find pi1 first. So it will be 1 by f of d square minus 4d plus 4 x square, right? So I'm going to apply type 3 here, right? Because RHS is of form x square, which is a polynomial in x. It will be 1 divided by, so take 4 outside. So 1 plus d square minus 4d by 4. And here, suppose here minus here, you take minus 4 outside, right? So in that case, you will have 1 minus x whole power 1 minus x whole power minus 1 formula. So since you have plus here, we are getting 1 plus x whole power 1 plus x whole power minus 1 formula. So we have 1 by 4, 1 plus d square minus 4d by 4 whole power minus 1 of x square. So this will be 1 by 4. So 1 minus x plus x square and so on into x square. So this will be 1 by 4, 1 minus d square by 4 plus 4d by 4. Here the first term is a square minus 2 times ab plus b square divided by 4 square is 16. And I'm omitting all the term. Because it is of order greater than or equal to d cube. D is 2x, d square is 2. So d cube, d power 4, all terms are 0. So that means I can cancel this d power 4 and d cube. So d square we will have the value. So this will be 1 by 4. So x square, I'm just multiplying this x square inside. So x square minus 1 by 4 d square of x square, which is 2 plus 4 by 4, which is 1. So d of x square is 2x. So we will have this to be 2x here, right? D of x square is 2x, and here we have 1 d square of x square is 2. So this will be 1 by 4. This will be 1 by 4 x square plus 2x. X square plus 2x. This will be 2. 2 minus 1 by 2. 2 minus 1 by 2. So 1 by 4 x square plus 2x plus 3 by 2. This is your PI1 value. Now you'll find PI2 and PI3, right? So PI2 is 1 divided by d square minus 4d plus 4 e power x, right? So how you do in type 1? So replace d by a. So e power ax. So a is 1 here. So replace d by 1. So 1 minus 4 into 1 plus 4 e power x. So these two will get cancelled. So denominator is non-zero. So this is what pi. If it is 0 means what we will do? We will multiply x and differentiate denominator, right? But this is not in our case. So we will find pi3 now. So 1 divided by d square minus 4d plus 4 of cos 2x. So replace d square is equal to, I'm applying type 2 here. So minus of a square. So minus of a is 2 here. So minus of 2 square. So you have to replace d square by minus 4. This will be minus 4 minus 4d plus 4 cos 2x, right? Okay, so these two are getting cancelled. If it is not getting cancelled means you take conjugate, right? Okay. This will be minus 1 by 4d cos 2x. So minus 1 by 4, 1 by d. Integration of cos 2x is sin 2x by 2. Right? So this will be minus 1 by 8 sin 2x is your pi3. Therefore, general solution is y is equal to complementary function is c1 plus c2x e power 2x, and pi1 is 1 by 4 x square plus 2x plus 3i2 plus pi2 is e power x minus pi3 is minus 1 by 8 sin 2x. This is your general solution. We'll move on to 7th problem. This is the last problem in type 3. So we can do any problem, right? Very simple RR. So solve d square plus d of y is equal to, actually UPSC question, x square plus 2x plus 4. You can take this as pi1, pi2, pi3, or you can take this as entirely as one pi and find pi, right? Good. General solution is y is equal to cf plus pi. I'm going to take this as single term and I'm going to apply type 4, right? Type 3, sorry. Type 1 is e power x, type 2 is sin x or cos x, type 3 is polynomial in x, right? You can either take all to be pi or you can do separately also pi1, pi2, pi3. For pi1 and pi2 you need to apply type 3, and for this type 1, because this is 4 into e power 0x. So replace d by a is 0 here. Okay. So to find cf, so the auxiliary equation is m square plus m is equal to 0. So if we take m common, we will have m plus 1 is equal to 0. So therefore the roots are 0 and minus 1. So cf is c1 e power m1x, c2 e power m2x, right? So c1 e power 0x plus c2 e power minus x is your characteristic function. So to find pi, so we have pi to be 1 by f of d, 1 by f of d into b, so x square plus 2x plus 4. So if we take this d outside, we will have 1 plus d square by t, right? 1 plus d square by t, x square plus 2x plus 4. So let us take this 1 by t outside. So this is 1 plus d. We cancel this 1 plus d whole power minus 1 x square plus 2x plus 4. So this will be 1 by d. So 1 minus x plus x square minus x cube and so on uh, into x square plus 2x plus 4, right, into x square plus 2x plus 4. So we have x square plus 2x plus 4. So d is 2x plus 2, d square is 2, d cube is 0. So d cube d power 4 will be 0, right? So this will be 1 by d. So multiply this 1 inside. So we will have x square plus 2x plus 4 minus d of this term. So d of that term is 2x plus 2 plus d square of that term is 2 and all of the term is 0, right? So just multiplying these terms inside, right? So d of this, d square of this and so on. So this will be 1 by d. So we will have this term to be equal to x square plus 2x plus 4 minus 2x minus 2 plus 2. These two will get cancelled. So we have x square plus 4x plus 4. This will be 1 by d of x square. Then these two also will get cancelled, right? So x square plus 4. So 1 by d means you have to integrate this. So which is x cube by 3 plus 4x. This is your pi. Therefore, general solution is y is equal to cf plus pi. So cf is c1 e power 0x is 1. So we'll have c2 e power minus x plus x cube by 3 plus 4x. So this is your partial integral, right? So 1 by d square plus d plus d. Okay, so that's it, right? We will stop solving problems based on type 3. Now we'll move on to type 4, right? So type 4 is, write it down. I'm on type 4. So type 0 is RHS is 0. Type 1 is RHS is e power x. Type 2 is RHS is sin ax or cos ax. Type 3 is a polynomial in x. Right? Very easy on. And one type 4, RHS is of the form. RHS is of the form. E power ax into v, right? That is v can be sin ax or cos ax. Okay, let's write it down. R is of the form e power ax into sin ax, right? If you have plus means you can easily very do, right? E power ax into sin ax or e power ax into cos bx or e power ax into polynomial in x. Right, polynomial in x. And write it here, polynomial in x of degree 1, right? If degree 2 means this method will be okay, polynomial in x, right? Okay, write it down. Polynomial in x, right? So if you have plus means very easy. What you will do? You just take this as PA1, apply type 1. Take this as PA2, apply type 2. And again everything here what you will do? You will take this as type 1 and you take this as type 3 and PA1 plus PA2. But here we have multiplication, right? Here we have multiplication in between these. That means this comes under type 4. Is it clear? See, type 1, type 2, type 3. Type 1 into type 2. Type 1 into type 3. Right? Type 1 into type 2. These two are type 1 into type 3. If you have plus means very easy. right? If you have plus means take this as PA1, take this as PA2, and find PA1 using type 1 and find PA2 using type 2, right? But here you have multiplication. You have to know the difference, right? Okay, that is we have so d power n a naught d power n plus an d power n minus 1, a2 d power n minus 2, and so on up to an of y, up to an of y is equal to e power ax into b, right? I'll put this as b. B can be sin ax or cos sin ax. You can also write cos ax also, right? Sin ax or cos ax or polynomial in x. This b can be. So how to solve this, right? How to solve this, right? The method of finding CF is same. The general solution is y is equal to CF plus PI. So find CF as usual, right? The method of finding CF is same. The method of finding CF is same. Right? That is, you find the auxiliary equation, find the roots. Now you have to understand this single step. Then problem is very easy. So to find a PI, right? So what is PI? 1 by f of d. This is your f of d, right? This is your f of d. This is your f of d. 1 by f of t e power ax into v. What you have to do is replace this d by d plus a. This a is here, right? You have to replace d by d plus a. So we have e power ax here, right? So replace d by d plus a. This work is completed now. This work is completed. So take that e power ax outside, right? So we have 1 by f of t plus a, because we are replacing d by d plus a into v. Now you proceed as, now you can see, now we know what is v, right? So v is sin ax or cos ax or polynomial in x. So this you have to proceed by the method of uh, type 2, type 1, type 2, 3, right? Suppose if you have v to be sin ax, means proceed by type 2. See, we have this e power ax. What that e power ax is doing is we are replacing d by d plus a and taking this outside. So that means this work is completed now, right? So now we will have 1 by f of d into v. Now this you find by you find this by type 2 or type 3. We will do problems, you will have more clarity. Okay, so we'll solve first problem. To solve d square minus 2d square minus 2d plus 1 of y is equal to x square e power 3x, right? So we have e power ax into x square. That means it comes under type 4. E power ax into v, here v is x square. Okay, solution. So the general solution is given by y is equal to CF plus PI, right? So to find a CF, it is very easy. To find the auxiliary equation, m square minus 2m plus 1 is equal to 0. So we have m minus 1 whole square is equal to 0. So we have 1, 1. So therefore the roots are real and distinct. C1 plus C2x, C1 plus C2x e power x, right? C1 plus C2x e power x. Okay. C1 plus C2x e power x. Now to find a PI, so PI is equal to 1 divided by f of d square minus 2d. So d square minus 2d plus 1 x square e power 3x, right? So what you have to do? Replace So replace, hello, nice. So we have 1 by d square minus 2d plus 1 x square e power 3x, right? So what you have to do is replace d by d plus a, right? There will be d plus 3. So it will be, so that means this work is completed now, right? E power 3x is completed now. That means e power 3x we can take that outside, right? So what this e power ax does is replace d by d plus a 1 divided by d plus d by d plus 3. So d plus 3 whole square 2 times d plus 3 plus 1 into x square, right? Is it clear up to now? So you just replace d by d plus a and take the term outside. So this will be equal to e power 3x 1 divided by d square a plus b whole square, a square plus 2 times ab plus b square minus 2d minus 3 plus 1 into x square, right? So this will be e power 3x 1 divided by d square. So 6d minus 2d, it is 7d. 9 minus 3 is 6. 6 plus 1 is 7. So we have d square plus 7d plus 7 of x square, right? Now you have to apply type 3 here, right? You don't, you as after you don't think about this e power 3x now, right? This work is completed. What this e power x does is you have to replace this d by d plus a. So take the term to left of this. That means you just only write this e power 3x, but it's not going to do anything from now, right? Now you just do this by type 3. So we have 1 by f of d into x, right? So check this a square plus 2 times ab plus b square minus 2d. Sorry, it is minus 6, right? Minus 6 minus 6 plus 1. So 9 minus 6 is 3. 3 plus 1 is 4. So we have d square plus 7d plus 4. Okay. So this will be e power 3x. So 1 divided by, that is 4 outside. So 1 plus d square plus 7d by 4. From now on, it is very simple, right? The only thing is you have to, what that e power ax does is just replace d by d plus a. That's it. X square. So this will be e power 3x. I think this 4 also outside. So e power 3x by 4. 1 plus d square plus 7d. 4d. Okay. 6d minus 2d is 4d. Yeah, 4d divided by 4. 1 plus x whole power minus 1 into x square. It will be e power 3x by 4. So 1 plus x whole power minus 1. So 1 minus x plus x square and so on into x square. So we have d square is 2x, d is 2. So we can consider only d is 2x, d square is 2. So d from d cube every term will be 0. So we have e power 3x by 4, 1 minus d square by 4 plus 4d by 4. And here we are going to have a square minus 2 times ab. So we'll have 8d cube plus b square divided by 4 square is 16 and so on into x square. So we can answer, we know to consider this term, right? Because d cube is 0, that means d power 4 will be 0. So e power 3x by 4, multiply this x square inside. So x square minus 1 by 4 d square of x square plus d of x square plus d square of x square. This is e power 3x by 4 x minus 1 by 4 d square is 2, d of this is 2x, d square is 2 again. So we have e power 3x by 4. So this will be x plus 2x plus 2 minus 1 by 2, right? Plus 2 minus 1 by 2. So e power 3x by 4, x square plus 2x, x square plus 2x 4 minus 1 is 3 by 2. This is your required particular integral, right? Okay. This is plus, right? D square plus 4d. This will be minus. So x square minus 2x, x square minus 2x plus 3 by 2 is your required particular integral, right? General solution is y is equal to cf plus pi. This is your pi and this is your cf, right? So only thing is, if you have plus means very easy, right? If you have plus means pi1 plus pi2, pi1 you have to find using type 3, pi2 you have to find using type 1, right? But your multiplication, that means it comes under type 4, e power x into v. V is x square here. Okay. One second problem. So solve d cube plus 3d plus 2 of y is equal to e power 2x sine 2x. This comes under type 4, right? We have multiplication here. So then solution, the general solution is y is equal to cf plus pi. So cf plus pi. So to find cf, so we have auxiliary equation m cube plus 3m plus 2 is equal to 0. So clearly you can see m is equal to minus 1, not minus 1 whole cube is minus 1, minus 1, minus 1 plus 3. Actually this d cube, d square, d square. So m square plus 3m plus 2 is equal to 0. So if you solve this, you will have minus 2, minus 1 are the roots. 4, minus 2, minus 6. Yes, are the roots. Therefore, your CF will be C1 e power m1x, C2 e power m2x. Now find pi. So pi is 1 divided by d square plus 3d plus 2 e power 2x sine 2x, right? So what is the work of this? Replace d by d plus a. So here e power ax. So replace d by d plus 2, right? So this will be 1 divided by, so this e power 2x work is done, right? So what is sum is plus? So here we have into. Okay. So we have this e power 2x work is done now. So this will be replace d by d plus 2. So d plus 2 whole square, 3 into d plus 2 plus 2 of sine 2x, right? So this will be sum of minus 2 minus 1 is minus 3. Why we need to find the sum for minus 2 and minus 1? See, this is completed. 1 by f of t e power x into v. We have to replace this d by, this is your a now, e power x. E power ax. So replace d by d plus a. A is 2. So it's e power 2x 1 divided by, so d plus 2 whole square. D square plus 4d plus 4. And here we have 3d plus 6 plus 2 sin 2x. So this will be e power 2x 1 divided by d square. This will be 7d. 4 plus 2 is 6. 6 plus 2 is 12. To sin 2x, right? So d plus d by d plus 2, d square plus 4d plus 4, 3d plus 6, d square plus 1d. Okay. So this you have to apply type 2 here. So e power 2x. Now you have to replace d square by minus of a square. Minus of, so a is 2, minus 4, right? You have to apply type 2 here because sin x. So 1 divided by minus 4 plus 7d plus 12 sin 2x. This will be e power 2x. E power 2x 1 divided by 7d plus 8. 7d plus 8 sin 2x. So this will be, you take conjugate now. 7d minus 8 divided by 7d plus 8. 7d minus 8 into sin 2x, right? I'm just multiplying and dividing by 7d minus 8. So e power 2x 7 into d of sin 2x minus 8 times sin 2x divided by, it will be 49 d square minus 64, right? A square minus b square. This will be e power 2x d of sin 2x. So it will be cos 2x into 2 minus 8 times sin 2x. So 49, and we know d square is minus 4. So we know d square is minus 4. Minus 64. So this will be e power 2x. See, this e power 2x is the work done, the work that is given by this e power 2x is replace d by d plus 2. Take this e power 2x aside, right? So 14 times cos 2x minus 8 times cos 2x minus 8 times sin 2x divided by 64. 49 into 4 is 136. 49 into 4, 196. 196, 64. 260. We have this 3 minus 260. I think you are not getting the answer. E power 2x sin 2x or e power 2x sin 2x. Okay, so this is the required answer, right? So e power 2x, 14 cos 2x minus 8 sin 2x by minus 260 is your required answer. Okay. Yes, this is your required answer, right? This is your PI. So therefore, the general solution is it clear? CF plus PI. So CF is this C1 e power minus C2 e power minus x. PI is e power 2x 14 cos 2x minus 8 sin 2x minus 260, right? Divided by minus 260. Okay, we want the third problem. To solve d cube minus d square plus 3d plus 5 of y. See, if you are well versed in type 1, type 2, type 3, type 4 is nothing, right? Type 4 is nothing but multiplication of e power ax into b. The only thing this e power ax is what it does is it replace d by d plus a and so on, right? Very simple. E power x cos x. If you have plus means pi1 plus pi2, but here we have multiplication. The general solution is y is equal to cf plus pi. So to find cf, see, I'm just tell you the roots for this. So it is m cube minus m square plus 3m plus 5 is equal to 0. So clearly you can see 1 is 1 root, right? Not 1. Not 1. It is minus 1, right? Because minus, this will be minus 1 m cube minus m square plus 3m plus 5. So if you, yes, if you put minus 1 means you will have minus 2 plus 2, which is 0. So m is equal to minus 1 is 1 root. So find the other roots. So 1 minus 1, 3, 5. So 0, 1 plus 0 is 1, minus 1 into 1 is minus 1. Add it up, you'll have 0. Minus 1 to 0 is 1 plus 0 is 1. Add it up, you'll have minus 2. So minus 1 minus 2 is plus 2. 3 plus 2 is 5. This will be minus 5 is equal to 0. Other two roots are solution of m square minus 2m plus 5 is equal to 0. To solve this, you will have m to be equal to 1 plus or minus 2y, right? B square minus 4ac divided by 2a. So we will have this. So therefore, the roots are one distinct root and one pair of complex root. So we will have CF to be equal to C1 e power minus x, e power alpha x, C2 cos beta x plus C3 sin beta x. This is your characteristic function. So we will find particular integral now. So Pi is 1 divided by d cube minus d square plus 3d plus 5 e power x cos x, right? So what is e power x does is replace d by d plus a, which is d plus 1 here, right? We have e power ax. If we have minus x means replace d by d minus 1, but we have 1x. So if we replace that, so this work is completed now. So we will have e power x, take that outside. So replace d by d plus 1. So d plus 1 whole cube minus d plus 1 whole square plus 3 times d plus 1 plus 5. Here we have only cos x, right? So we have to simplify this term. This will be a long term, right? We have e power x 1 divided by, so a plus b whole cube. I write it here. So a cube plus 3a square b plus 3ab square plus b cube. And here we have minus of this term. So minus of a plus b whole square. A square plus 2ab plus b square. I'm just taking minus outside also. Plus 3d plus 3 plus 3d plus 3. And here you have plus 5. So add it up, you will have d cube plus 2d square and 3d plus 3d is 6d. 6d minus 2d is 4d. So you will have plus 4d. 5 5 plus 3 is 8 into cos x, right? Now we have to replace, you have to do type, you have to apply type 2 here. So replace d square by minus of a square, so cos ax, so minus of 1 square, which is minus 1, right? Cos ax, so this will be e power x 1 divided by, so d cube is what? D cube is d into d square, it will be minus d, because d square is minus 1, so d cube is minus d, 2 times d square, d square is minus 1 plus 4d plus 8 cos x. So this will be e power x 1 divided by 4d minus d is 3d, 3d plus 6, 3d plus 6, and here we have cos x, so take conjugate, conjugate now, e power x 3d minus 6 divided by 3d minus 6, 3d plus 6 cos x, or you can take 3 outside, it will be easy for, right? Let's take this 3 outside. If we take this 3 outside, we will have 1 by d plus 2, right? In case it will be easy. So 1 divided by, if we take d outside, we will have d plus 2 cos x. So e power x by 2 d minus 2 divided by d plus 2 d minus 2 cos x. So this will be d of cos x e power 2x by 2 d of cos x minus 2 cos x divided by a plus b, a minus b, so it will be a square minus b square, and we know d square is minus 1, it will be e power 2x by 2, so d of cos x is minus sin x minus 2 times cos x divided by minus 1 minus 4, right? Because we know d square is minus 1, so this will be e power 2x by minus 10, so minus 5 into 2 is minus 10, minus sin x plus 2 cos x. This is your required solution. Okay, you have to take 3 common, right? It will be 1 by 3 be minus 15. Actually, we are not getting the answer. Is it correct, right? Everything we are doing, right? D cube minus d square plus 3d plus 5. So a plus b whole cube. So we have a cube plus 3 a square b plus 3 a into b square plus b cube, and minus a square, okay, 3d plus 3, and we have 5. So d cube plus 2d square. Just a minute, just a minute. D cube, here we have d cube plus 2d square, 6d minus 2d is 4d, right? 4d, and we have this to be 8. Okay. So we have d cube plus minus d minus 2 plus 4d plus 8, so 3d plus 6. They have given minus, I don't know whether I have done this wrong or not. They have given the answer as 3 sin x plus 5 cos x. Next time I take the answer. They are given e power now written e power 2x here. It's e power x only. They are given 1 by 34 in the denominator. So I'll just check the question once again. Into e power x cos x. Now I don't know where I took that question. They didn't correct, right? Just check the question once again. I don't know. Actually, I'm using so much of books for reference. I don't know from which book I take this question. Yes. D cube minus d square plus 3d plus 5 is equal to e power x cos x. If we replace d by d plus 1, d cube minus d square d plus 1 whole cube minus d plus 1 whole square plus d plus 1. See, they are written this as d cube minus d square plus 4d plus 7. Wrong, right? Actually, they are given wrong. Actually, what they have written this as um, d cube minus d square. How will it become minus d square? It is plus 2d square only, right? So a cube plus 3 times a square b, so which is 3d square. And here we have 1d square. So if I bring minus here, you will have 2d square. That only, right? So this, I think it is problem, right? While replacing d square, they have written this term as d cube. They have written this term as d cube minus d square plus 4d plus 7. That is not possible, right? They have written this as minus d square here. How it is minus d square is possible? A cube plus 3a square b plus 3ab square. So we have 3d plus b cube. And here we have a square, which is d square. So if we subtract, we will have 2d square only, right? Yes, I think the problem, I think there will be problem in the textbook. This is PI. This is your PI, right? Yes, all correct only, right? Yes, okay. So I think there is a problem in the textbook. So this is your required PI. Therefore, the general solution is y is equal to CF plus PI. So CF is this term and PI is this term, right? Here minus 2 minus sin x minus 2 times cos x divided by minus, in next page minus 2 is where minus 2. Square minus 4. Not only, right? Minus sin x minus 2 cos x actually minus 15. Yes, okay. This is your solution. I think we have wasted time checking the solution. Okay. Not the fourth problem. So solve this is a UPSC question. So solve d power 4y by dx power 4 plus 6 times d cube y by dx cube plus 11 times d square y by dx square plus 6 times dy by dx 6 times dy by dx plus 6 times when replacing these one minus 1 this one minus 1. In approach here you are telling by replacing d square is equal to minus 1. Here I have replaced d square. Here I have replaced this. So minus d 2 into minus 1. 4d minus d is 3d. 3d plus 6. Again this is d square minus 4. D square is minus 1. Okay. So my 6 times dy by dx is equal to 20 times e power minus 2x sin x. So this is an UPSC question. Solution, right? So we'll solve this. General solution is y is equal to CF plus PI, right? CF plus PI. So we'll solve this very fast. We have 20 e power minus 2x. Yes. So to find CF, we'll solve CF. To find CF, so we have m power 4 plus 6m cube plus 11m square plus 6m is equal to 0. This is our auxiliary equation, right? This question is same as d power 4 plus 6d cube plus 11d square plus 6d of y. Y is d by dx, right? Is equal to 20 e power minus 2x sin x. So solve this. So you will have, if you take m common, we will have m cube plus 6m square plus 11m plus 0. So you can see 1 is 1 root, sorry, 0 is 1 root, and solve this equation, right? You will get the roots to be equal to, -1, -2, -3. So minus 1 is 1 root clearly, and the other two roots by synthetic division. So these are the roots, all are real and distinct. So CF is C1 e power 0x, C2 e power minus x, C3 e power minus 2x, C4 e power minus 3x, right? Now we'll find Pi. So Pi is equal to, Pi is equal to find Pi. So we have Pi to be equal to, you are sending me on photo, right? So there you can see 7 will not come. So if you add it up the constant term, you will have 8 only, right? Because that -1 and +1 will get cancelled. So -1 +1 will get cancelled. So we have only 8 only as constant term, not 7. So we have 1 5 d power 4 plus 6d cube plus 11d square plus 6d. So 20 times e power minus 2x sin x, right? Now what you have to do is replace d by d plus a. A is -2 here, so replace d by d minus 2, right? Replace d by d minus 2. So this 20, you can take this outside. E power minus 2x work is done now. So we will have this to be d minus 2 whole power 4, 6 times d minus 2 whole cube, 11 times d minus 2 whole square, plus 6d, d minus 2, right? D minus 2. Now we will have sin x. We will have sin x. So a is -2 here, right? You just simplify this. So 20 into e power minus 2x. So you can write this as, if you know a minus b whole power 4 formula, write it out. If not, you do this as d minus 2 whole square, d minus 2 whole square. So expanding a minus b whole square formula and multiply it, and a minus b whole cube formula, a minus b whole square formula. You just do it. You will get the simplification as d power 4 minus 2 times d cube minus d square plus 2d. This is what you will get after simplification, right? This is what you will get after simplification, right? So just expand in you write as d minus 2 whole square, d minus 2 whole square. So d minus 2 whole square, you know, right? A minus b whole square formula. You simplify it, you will have d power 4 minus 2 d cube minus d square plus 2d. This is what they given in the textbook. Very easy to simplify, right? Now you have to replace d square by minus of a square. I'm going to apply type 2 here. So minus of d square by -1. This will be 20 e power minus 2x. 1 divided by, so d power 4 is d square, which is plus 1. This plus 1. D cube is d square into d. So d square is -1. So it will be minus d square is -1 plus 2d sin x. So this will be 20 times e power minus 2x, 1 divided by, so minus 2d plus 2d will get cancelled. You will have Yes, this will be 2D plus 2D, right? 2D plus 2D is 4D. And here we will have 1 plus 1 is 2. So we will have 4D plus 2 sin x. We can take this 2 outside. So 20 e power minus 2x by 2. This will be 1 plus 2D sin x. Right? 1 plus 2D sin x or 2D plus 1 sin x, whatever you can do. Now this will be 10 times e power minus 2x. So 1 minus 2D divided by 1 plus 2D into 1 minus 2D. I'm just thinking by its multiply by its conjugate. Sin x. This will be 10 e power minus 2x. This will be, if you multiply this term to this, we will have sin x minus 2 times d of sin x divided by a square minus b square. And we know d square is minus 1. So this will be 10 times e power minus 2x sin x minus 2 times d of sin x is cos x divided by 1. This will be 5. This will be 5, right? This will be 5. So 5 ones are 5 twos are. So we will have the answer to be equal to 2 times e power minus 2x. 2 times e power minus 2x sin x minus 2 cos x. This is your PI. So therefore, the general solution is y is equal to CF plus PI. Right? So CF, this is your CF, and this is your PI. Is it clear? It's very simple problem, right? So type 4 is very easy. Type 4 is just nothing but if you know type 2 and type 3, you can easily do. Sorry. See, other 3 roots are a 10th standard problem, right? You are solving this cubic equation. You know how to solve cubic equation, right? It's 10th standard level that is. So you can see minus 1 is 1 root. So minus 1 is 1 root means you just do by L method. So minus 1 is 1 root for this. So after doing that minus 1 is 1 root, the coefficients of this are 1, 6, 11, 1, 6, 11, 6. Now first you have to put 0 here. 1 plus 0 is 1. Minus 1 into 1 is minus 1. 6 minus 1 is 5. 1 into minus 1 into 5 is minus 5. 11 minus 5 is 6. 6 into minus 1 is 6. So that means 1 minus 1 is 1 root. If this root only, we'll have this as 0. Now you solve this quadratic equation. M square plus 5m plus 6. You will get minus 2 and minus 3. So therefore 0, minus 1, minus 2, minus 3 are the roots. So we'll do last problem we will do last problem in type 4, and then we'll move on to type 5, and then we'll wind off this. So solve d square y by dx square minus 5 times dy by dx plus 6y is equal to e power 4x into x square plus 9. X square plus 9. X square plus 25. Yes, e power 4x x square plus 9. Okay. So we'll do this very fast. So we have d square minus 5d plus 6 of y is equal to e power 4x x square plus 9, right? So therefore, first find CF. So it is m square minus 5m plus 6 is equal to 0. So solve this, you will have m to be equal to, solve this, you will have m to be equal to 2, 3. So therefore, your CF is C1 e power 2x, C2 e power 3x. Find PI. So it is PI is equal to 1 divided by d square minus 5d plus 6 e power 4x into x square plus 9. So replace d by d plus 4. So this work is completed now. So e power 4x, take it outside. So we have 1 by d plus 4 whole square minus 5 times d plus 4 plus 6 of x square plus 9. Now you have to apply type 3 here. This will be e power 4x 1 divided by a square plus 2 times AB plus B square. And here we have minus 5D minus 20 plus 6 x square plus 9. This will be e power 4x 1 divided by d square. So 8d minus 5d is 3d. 16 minus 20 is minus 4. Minus 4 plus 6 is plus 2. X square plus 9. So take this 2 outside. So this will be e power 4x. This will be 1 plus d square plus 3d by 2. And here we have x square plus 9. So it will be e power 4x by 4. 1 plus d square plus 3d by 2 whole power minus 1 into x square plus 9. This will be e power 4x by 4. So multiply this. So 1 minus x plus x square and so on into x square plus 9. So we have d is 2x and d square is 2, right? 2x, 2x plus 0, 2. So from d cube every term will be 0. So we have e power 4x by 4. So 1 minus d square by 2 minus 3d by 2. And here we have a square minus 2 times ab plus b square divided by 4. And here we have x square plus 9. So this terms will be 0. So we have e power 4x by 4. So 1 minus 1 by 2. Let's multiply this x square inside. So we have x square plus 1, x square plus 9 into 1 is x square plus 9 minus 1 by 2 d square of x square plus 9 minus 3 by 2 d of x square plus 9. And here we have one term which is 9 by 4 d square of x square plus 9. This will be e power 4x by 4 x square plus 9 minus 1 by 2 d square of this will be 2 minus 3 by 2 d of this is 2x plus 9 by 4 d square is 2. So this will be e power 4x by 4 x square. This will be 2 will get cancelled. So x square minus 3x 2 will get cancelled. So 8, sorry, 9 minus 1. 9 minus 1 is 8. 8 plus 9 by 2. 8 plus 9 by 2. So we will have this term to be equal to e power 4x by 4 x square minus 3x. 16 plus 9 is 25. So plus 25 by 2. This is your required particular integral, right? It's x square minus 3x 25 by 2 1 by 2 e power 4x. Okay. I don't know why I done 4 here. I done 4 here. Lots of mistake today. Okay. So we'll move on to type 5 now. Actually, type 5, we will do in type 5 we'll do 3 problems, right? We will do 3 problems and then we will do 2 special problems. We will do 2 special problems and then we'll wind off. So overall we're going to do 5 problems. So we'll be doing 5 problems now. So we will move on type 5. So type 5 is RHS is of the form x into v, right? So in type 4 we have e power ax into v, right? E power ax into v. So e power ax into sin ax, e power ax cos ax, e power ax polynomial in x, right? Now in here what we're going to do is we're going to x into v, right? So type 5 is RHS is of the form x into b, right? So b is a function of x. This b can be sin x, it can be sin 2x, it can be cos 2x, and so on, right? But if you have e power x, you can do that. You can do that in type 4, right? B is a function of x. If b is equal to e power x, you can do in type 4 or type 5, that I'm going to list out the formula for type 5. Right? If it is e power x, if this b is e power x, means you can do in type 4 only, right? Replace d by d plus a. This e power x work will be completed. Now we have only b here. Sorry, we have only x here. So you can do in type 3 for that x. Clear? So if you have b to be e power x, means you can do in type 4. Right? What is type 4? E power x into x. So replace d by d plus a. You will have only x here. So 1 by f of d into x. Further you apply type 3. Right? Okay. Now I'm going to give the formula for type 4. When you have x into b, that is your we have a linear differential equation a naught dn, an dn minus 1, and so on up to an of y is equal to x into b. This b is a function of x, right? This is a function of x. The method of finding CF is same. The general solution is y is equal to CF plus pi. The method of finding CF is same. Method of finding CF is same. Now to find pi, right? So what is pi? 1 by f of d into xb, right? That is 1 by f of d into RHS. RHS is x into b. This b is a function of x. I'm going to give the formula. 1 by f of d x into b is same as x into 1 by f of d into d minus f dash of d divided by f of d whole square into b. This is the formula, right? Whenever you have x into b, if you have v to be e power x, you can either use this formula or you can do in type 4. Other than e power x, if b is sin x, if b is sin 2x, if b is cos x, you can use this formula. So x into 1 by f of d into b minus f dash of d by f of d whole square into b. You have to remember this formula, very important, right? We'll do the problem straight away. Problems. Solve. Submit. Is there any doubt up to now? See, x into b. See, all of these, right? Type 0 is r is e power x. Type 1 is r is sin ax or cos ax. Type 3 is r is polynomial in x. Type 4 is e power x into b. Type 5 is x into b. Okay, x into b. Okay. So solve e square plus 4 of y is equal to x sin x. X into sin x. You can see x into b, right? So we'll do this very fast. Solution. So the general solution is y is equal to CF plus pi. So first you find CF. The auxiliary equation is m square plus 4 is equal to 0. So m is equal to plus or minus 2i. So it is of the form 0 plus or minus 2i. Therefore, your CF is e power alpha x c1 cos beta x plus c2 sin beta x. So e power 0x c1 cos 2x c2 sin 2x, right? This is your CF, or c1 cos x c2 c1 cos 2x c2 sin 2x, right? Now it's very important part. So what is PI? 1 divided by f of d into v, right? So you can see 1 by f of d xv, x into v. What is formula? 1 by f of d into v, 1 by f of d into v minus f dash of d by f of d whole square into v again. This is the formula, right? 1 by x into 1 by f of dv minus f dash of d by f of d whole square into v. Here f of d is what? Here f of d is d square plus 4. This will be x into 1 by f of d into v minus f dash of d. This is 2d by f of d whole square into sin x. So here you have to apply type 2. Here you have to apply type 2 again. Right? You don't need to consider this x. So whenever some term is left of this, you don't need to consider when we are performing this. So we have x into 1 by d square plus 4 sin x minus 2d by, you can also expand here, right? Or else just keep this as it is, d square plus 4 whole square sin x. So you have to replace d square by minus of a square, right? Replace d square by minus of a square. In that case, it is minus of a is 1. So that means this will be x into 1 by, so d square is minus 1 plus 4 sin x minus 2d divided by, so d square is minus 1. So minus 1 plus 4 whole square sin x. So this will be x by 3 sin x minus 2d by 9 sin x. So this will be x by 3 sin x minus 2 by 9 d of sin x. So d of sin x is cos x. This is your required particular name. Very easy, right? So we have x into v, right? X into v. So x into 1 by f of dv minus f dash of d by f of d whole square into v. So apply type 2 in both the scenarios, right? 1 by f of d, also let b here, right? This is the formula, right? X into 1 by f of d into v minus f dash of d by f of d whole square into v. This is the formula, right? Just apply the formula, apply type 2 here. Very easy. Okay. I'll move on to second problem. Is it clear? General solution is y is equal to cf plus pi. You have to write here, right? In all the questions, I'm just writing only this term. You have to write cf and you have to write pi and add it up, right? I'm just writing this term, but you have to write in the exam both, add it up. Okay. Second, solve d square minus 2d plus 1 of y is equal to x e power x sin x. How you have to do? Very simple, right? We have e power ax. What you have to do here? You have to replace d by d plus 1. So this e power x work will be completed. We have x into sin x. For that you apply type 5. Right? Let's do this. So we have CF. Oxide equation is m square minus 2m plus 1 is equal to 0. This is same as m minus 1 whole square is equal to 0. So m is equal to 1 are the roots. So therefore the CF is c1 plus c2x e power x, right? Now very important part. So 1 by d square minus 2d plus 1 x e power x sin x. This I can write this term as 1 by d minus 1 whole square, so that it will be easy. Now this what this e power x does is replace d by d plus a. So here a is 1, e power 1x. So this e power x part is completed. So this e power x take outside. Now replace this d by d plus 1 into x sin x. Right? Now you have to apply type 5 here, x into v. So this will be e power x 1 by d square x into sin x. Right? So you can integrate this twice, or you can apply that formula also, right? 1 by d square means what? You have to integrate twice. or you can use the formula. So e power x, x into 1 by f of d into b minus f dash of d by f of d whole square into b, right? So this will be e power x, x 1 by d square of sine x minus what is f dash of d? 2d f of d whole square, which is d power 4 sine x. So this will be e power x. So what is 1 by d square of sine x? 1 by d means integration. Sin x integration is minus cos x minus cos integration is minus sine x. So we will have this to be minus sine x overall. See, 1 by this means we have to integrate twice. So the integration of sin x is minus cos x. Integration of minus cos x is minus sin x, right? And here we will have minus 2 times d cube sin x. Now we have to integrate this 3 times, right? Because we have 1 by d cube, 1 by d, 1 by d, 1 by d. This will be e power x minus x sin x minus 2 times d cube of sin x. First term integration is minus cos x. Second term is minus sin x. Third term is plus cos x. So this will be e power x minus x sin x minus 2 times cos x is your required particular integral. Is this clear? See, you have 3 terms here. So whenever you have this term, you just replace d by d plus 1. So we have x into v, apply type 5. So therefore, the general solution is y is equal to cf plus pi. Okay. Now move on to third problem. To solve d square plus 1 whole square of y is equal to 24x cos x. This is UPSC question. It is given that y dy d square y is 0 and d cube y is 0 when x is 0. Where d square has minus 1? Yes. You can do that also. Even I forgot. See, if I do that means we will do this very easily, right? So if I replace d square by minus 1, we will have minus sin x. Yes, very good. Actually, I also forgot to do that. So 1d will get, and we have d cube. So this will be d square into d. So d square is minus 1, minus will become plus, and 1 by d of sin x is minus cos x. Same answer only will be getting, right? Yes. Yes, good. So d square is minus 1, so we have minus sin x. That is what we will have here. And here, if you replace d square by minus 1, you will have d square into d. So it will be plus d. So we'll have plus 2 times 1 by d sin x, and 1 by d sin x is minus cos x. So we'll have minus 2 cos x. Same only you'll be getting, right? Yes, good. You can do that. You can replace d square minus half a square. Even I forgot to do that. Okay. So we'll do this, right? We'll do this very fast. This is very easy, right? Y is 0 when x is 0. What is d? D is d by dx. So dy by dx is 0 when x is 0. D square y by dx square is 0 when x is 0. We know d is d by dx, right? So dy by dx is 0 when x is 0. So they are given this just to find out the values of the arbitrary constant that we are using in CF. Okay. The solution. So we have the general solution is y is equal to CF plus pi. So first we will find CF. The auxiliary equation is m square plus 1 whole square. That means m is equal to plus or minus I twice. So we will have whole square, right? That means we will have multiplicity to be equal to twice. And here the roots are plus or minus I. So it means we have 2 pairs of equal complex roots. So 2 pairs of equal complex roots. Then what is your CF? C1 plus C2x e power alpha x C1 plus C2x, that is e power alpha x C1 plus C2x cos x cos beta x, which is 1 here, plus C3 plus C4x sin x, right? So e power 0 is 1. So we will have C1 plus C2x cos x, C3 plus C4x sin x. This is your CF. Now to find PI, the particular integral is 1 divided by d square plus 1 whole square 24 times x into cos x. 24 times x into cos x. So how you will do? So 24 x into v. So 1 by x into 1 by f of dv, x into 1 by f of d into v minus f dash of d by f of d whole square into v. So this will be 24 x into 1 by f of d is d square plus 1 whole square cos x minus f dash of d. So what is f dash of d? So you have to differentiate this. You can either expand in a plus b whole square formula or simply. Okay, so we'll do this, right? So 1 by f of d into b minus f dash of d. So you just expand d plus 1 whole square as a square plus 2 times ab plus b square. A square plus 2 times ab plus b square, right? So if you differentiate this, you will have 4d cube plus 4d. This will be 0. So f dash of d will be 4d cube plus 4d divided by f of d whole square, which will be plus 4 cos x, right? So we have to replace d square by minus of a square, which is minus 1 minus of 1 square. So this will be 24 times x into 1 by d square by minus 1 means so this will be what? This will be 0, right? You have to do some other method, or else it will take so much of time, because you can see this is 0. So that means minus 1 plus 1 will be 0 into cos x minus we will have 4d cube plus 4d divided by again we will have minus 1 plus 1 whole power 4 cos x. So that means it will take so much of time, right? Okay, that means what you have to do if you have 0 here, you have to multiply 1x and then you have differentiate its denominator, right? Multiply 1x and differentiate denominator, and here also multiply 1x and differentiate denominator, right? So we will have 24. To multiply 1x, we will have x square, and you have to differentiate the denominator. So 2 times d square plus 1, 2 times d square. I think you can do this, right? Because d square plus 1 is 2. To differentiate this, we will have 4d cube plus 4d. d cube plus 4d cos x, and here we will have 4d cube plus 4d as it is. You have to differentiate this again. 4 times d square plus 1 whole cube into 2d into cos x. No, I think this will take so much of time when I do like this, right? We have to, unless you get the non-zero denominator, if you replace d by minus 1, you will have again to be, if you replace d by minus 1, again you will have this term to be 0, right? Again you will have this term to be 0, but this term will be non-zero. If you replace d by minus 1, so this will be minus 4 minus 4. This will be minus 8, right? Minus 8. See, is it clear, right, what we are doing? Four x cos x. D square plus 1 whole square plus 1 whole square. Okay, what we'll do is, actually we can do this. This will be, if we replace d by minus 1, we will have minus 4 minus 4, right? 4 times d square plus 1, 4d d power 4 plus 2. Yes. You can do this, you can do by this method, right? This will be 0, you have to do again and again and again. Let us pass this at a moment, right? Let us pass this at a moment. We will come back to this problem later, right? We will solve, actually we have solved 3 problems in this case, right? That is x into b. Now we will solve a special case, right? Special case of type 5. Special case of type 5. That is RHS is of the form x square into b, right? X into b, here we have x square into b, right? If we have x square into b, how we have to do? So we will see 2 problems based on this, 1 or 2, right? 1 or 2 problems based on this, and then we will try to apply whether we will try to do whether we can do that problem in case 5, right? If we do it, if we do some problem in case 5, means it may be easy. Let us try. Let us give you some problems on a case, special case of type 5, and then we will move on. So we are in the final part of solving this entire problems. Yes. So I'll do one problem on this is very rare case, very rare case, but I'll do one problem. I'll do the problem. First problem is solve. So solve b square plus 4 of y is equal to x square cos 2x. See, you can do this in case 4 also. Sorry, type 5 also. Right? You don't even consider this into type special case. Why? Because you can also do in the previous method also. That is, if you have x into x cos 2x. So for this, you take this as b, right? So that we will have 1 by f of d into b minus f dash of d by f of t whole square into b. Now b is what? Now b is x into cos 2x. Now again you have to apply the formula. 1 by, again you have to apply the formula 1 by f of t x into b. Right? That it will take so much of time. That is, you have to apply formula twice if you do in that method. But I'll give you a shortcut. If you have x square, right? If you have x square into b, how we have to do, right? We will do in some other method. Okay. So CF is very easy, right? CF is m square plus 4 is equal to 0. So we have m is equal to plus or minus 2i. Therefore CF is e power 0x C1 cos 2x, C2 sin 2x, right? Actually, I have passed this problem. We'll come back to this problem after finishing this problem, right? We're going to do only one problem in type 5, result case of type 5. Okay. So here we have what is our PI? So PI is 1 divided by d square plus 4 x square cos 2x, right? X square cos 2x. So what I'm going to do is a very important thing here. I'm going to write this cos 2x as we know e power ix, right? What is e power I theta? Cos theta plus I sin theta, right? That means I can write e power ix as cos x plus I sin x. Now what will be e power I 2x? It will be cos 2x plus I sin 2x, right? So I can write this cos 2x as real part of this term. Yes or no? Cos 2x is real part of this term. Sin 2x is imaginary part of this term. So I can write this as 1 by d square plus 4 x square. So cos 2x is real part of e power I 2x. So instead of cos 2x, I'm writing this term, right? Real part of e power I times cos 2x. Now we have e power ix. That means what? Replace d by d plus a. This term, this part will be completed. This work will be completed by that, right? So what I'm going to do is I'm going to replace d by d plus a. So here a is 2i, e power ax. So a is 2i. So replace d by d plus 2i. So this work is completed now. So real part of e power I 2x 1 divided by d plus 2y whole square plus 4 of x square, right? I'm just writing cos 2x as d plus 2y whole square plus 4. So we have real part of e power I 2x. So 1 divided by a plus d plus 2y whole square, right? D plus 2y whole square plus 4. Okay, so what about this term? So a square plus 2 times ab plus b square. It will be 4 minus 4, right? Because I square is minus 1. So plus 4 of x square. So these two terms will get cancelled. So this will be real part of e power I 2x 1 divided by. So I have to take 4di outside, right? Because 4di is outside. 4di outside. So if I take 4di outside, we will have 1 plus d square by 4di. And here we have x square, right? We are applying type 3, right? RS is of the form polynomial in x. So we have this to be a real part of e power I 2x. And we have 1 by 4 di, right? 1 by 4 di, 1 plus d square by 4 di whole power minus 1 x square, right? Now we will do this. So real part of e power I 2x 1 by 4i into 1 by d. And what about this term 1 plus x whole power minus 1? Before that I can cancel this 1d. So 1 plus x whole power minus 1. So 1 minus x plus x square and so on, right? So we have d to be 2x, d x square, d is 2x, d square is 2, d cube will be 0. So I'm not considering d cube term. So this will be real part of e power I 2x 1 by 4i 1 by d. So 1 minus 1 by 4i 1 by 4i d of x square is 2x plus 1 by 16i square, d square of x square is 2, right? So this will be real part of e power I 2x. We have 1 by 4i 1 by d. So here also we have x square, right? I'm multiplying this x square inside. So 1 into x square is x square. Okay. So here we have x square minus 2 1s are 2 2s are. x by 2i and I square is minus 1. So we have 2 1s are 2 8s are. So we have minus 1 by 8. Right? We have minus 1 by 8. Okay. Now d square is 2x d is 2. Okay. Clear, right? Okay. Now you have to integrate this term, right? 1 by d. So real part of e power I to x 1 by 4i. To integrate this, this will be x cube by 3 minus x square by 4i minus x by 8, right? This we are integrating. Here we are integrating x cube by 3, x square by 2, so root 2 will be 4. Yes. So we have this term. Now multiply this 4i inside. So real part of um, okay, so this will be real part of e power I to x. I can write this as, let us multiply this I, let's multiply this I here, let's multiply I here. So this will be I square is minus 1. So we have to multiply minus I by 4 with x cube by 3 minus x square by 4i minus x by 8, right? This will be real part of e power I to x into, if we multiply this minus I by 4 inside, we will have minus I times x cube by 12 plus I times x square by 16i plus ix by 32, right? This is what you will have to multiply this term. Now this will be equal to real part of e power I to x. See, this seems to be a little bit vague, but very easy. If you practice one time, it will be very easy. So this will be real part of e power I to x. And here we have these two as imaginary part. So if I take the I will get cancelled. So these two are imaginary part. So if I take I outside, I take I outside with minus x cube by 12 plus x by 32. This is your imaginary part plus x square by 16 is your real part, right? Okay. Now, this is equal to real part of e power I to x. We have this term, right? Okay. Now, what is real part of this term? What is real part of this term? What is real part of this term? So we have, this is cos 2x plus I sin 2x, right? What about the real part of this term? We have to consider real part of this term, right? So, so we have a real part of, so e power I to x is cos 2x plus I sin 2x. Again, you revert back to this, and then here you will have I into minus x cube by 12 plus x by 32 plus x square by 16. Now, what are the real part you will have? If you multiply these two terms, you will have 4 terms. Out of these 4 terms, you take only the real part, right? What is the real part? So this into cos 2x into this term will be a real number, real part. That means we don't have I here. So one term will be cos 2x x square by 16. And when you multiply cos 2x with this term, you will have I into something which is imaginary. When you multiply this into this, you will have again real part. I into I is I square. So we have I square is minus 1. So we have sin 2x into, we have sin 2x into sin 2x into minus x cube by 12 plus x by 32, right? So this is equal to x squared by 16 cos 2x plus x cube by 12 sin 2x minus x by 32 sin 2x. This is your particular integral. Is it clear? Is it clear? Very simple. So when you have x square, right? If you have x means very easy. 1 by f of t into b minus f dash of t by f of t whole square into b. So if you have x square, you consider this term. You can also do this method for the previous cases also. I'll let you know. I'll do one more problem there also. So if you have x means you can directly use this, right? You can also approach the same problem by that method also. I'll let you know. I'll do this after this. So we have, I'll repeat once more. So I'm writing this cos 2x as e power real part of e power I 2x. Suppose if you have sin 2x means what you will do? Imaginary part of e power I 2x. If you have sin 2x means what will be the answer? Same question. If you have sin 2x means the answer will be imaginary part. You'll be calculating the imaginary part. So you will have cos 2x into this term will be imaginary and the sin 2x into that term will be imaginary. So those two terms will be the required particular integral. But here we have cos 2x. That means we are writing this as real part of e power I 2x. Is it clear? If you have sin 2x means the answer will be the other two terms. That is, you take the imaginary part. But we have real part cos 2x. That is nothing but real part of e power I 2x. So you replace d by d plus 2i and take this term outside, and you do this by type 3. So 1 by replace, we have a polynomial in x, so take that last d's degree outside. So 1 plus x whole power minus 1, very easy. And we are 1 by d here, integrate 1 by 4i multiply, and the real part of you again replace this e power I 2x by cos 2x plus I sin 2x. So you will have 4 terms, collect only the real part. That will be the answer. Is it clear? Therefore, the general solution is see, you can do this problem also in this method. That is, we have solved the first problem in type 5, right? X into v. You can do the same problem like we did there. I do it now, right? So what is your pi? Pi is 1 divided by d square plus 4 x into x into sin x, right? I can write this sin x as imaginary part of e power ix, right? I'm going to write sin x as imaginary part of e power ix. So replace d by d plus I, because e power x, a is I here. So this imaginary part of, so e power ix, you can take that outside. 1 divided by, replace d by d plus I, so d plus I whole square plus 4 of x, right? So this will be imaginary part e power ix 1 divided by, so a square plus 2ab 2 times id plus b square, I square is minus 1, you will have plus 4 of x. So this will be imaginary part of e power ix 1 divided by d square plus 2id 4 minus 1 is 3 into x, right? See, I'm doing the same problem in different way. That's it. Don't get confused. This will be imaginary part of e power ix. So we take this 3 outside. We have d square plus 2id by 3 is 1 plus into x. So this can be written as imaginary part of e power ix. Let's take this 1 by 3 outside. 1 plus d square plus 2id by 3 whole power minus 1 into x. So this will be imaginary part of e power ix into 1 by 3. So 1 minus x plus x square and so on into x. So d of x is 1. So d square itself 0. D square itself 0. That means d square will be 0. And here every term will be of order greater than or equal to 2 only, right? D square plus 2id whole square. So a power 4, this will be d power 4, 2d cube, 2 times ab will be d cube order, and this will be d square order. So don't need to consider this term. So it will be imaginary part of e power ix 1 by 3. So multiply this x inside. So we will have x minus 2y by 3. T of x is 1. Right? So this will be imaginary part of e power ix x by 3 minus 2y by 9. Right? X by 3. I'm just multiplying this 3 inside. So now you consider imaginary part of what is e power ix? Cos x plus I sin x, x by 3 minus 2y by 9. Now you take only imaginary part. So this will be real part. This will be imaginary part. So minus 2 by 9 cos x is one imaginary part. And if you multiply this, here you will have imaginary part, which is x by 3 sin x. This is the same answer which we got there. X by 3 sin x minus 2 by 9 cos x. You can do this problem this way also. So x into v means you apply the formula, but if you have x square into v means you go by this method. That is real part or imaginary part. Is it clear? Is it clear? See, x into v also you can go by this method also, but formula method is very easy, right? But if you have x square into something, formula method will be very long. So you have to go for this method. This method is also very easy only. If you do one or two problems, it is very easy. See, 4 are watching. Is it easy, right? So here we have 4 terms. You collect only imaginary parts. Because we have sin x, right? Suppose same question, if you have cos x means the answer will be you collect the real part, right? Any doubt? I want to repeat. Today I want to repeat. Okay. This is what special case, right? So I think you can do problem special case also from now on. Okay. Now we'll come back to this problem, right? Uh, Clear, right? Okay, Vicky. Okay. So now we'll move on to the actually the that is completed, right? I'll give some exercise problem in Telegram group. I'll give some exercise problem in Telegram group. Before that, actually we are done with this topic, right? Type 1, type 2, type 3, type 4, type 5, and one special case of type 5. Now we'll come back to this problem which we left, right? Actually, when we do in this method, it takes so much of time to find a particular integral, right? So we have 1 by f of dxp. You can see it is taking so much of time. So what I'm going to do is, let us try to apply that method here. Let us write this cos x as imaginary part of, real part of e power ix. Let us see whether we are getting solution easily when I do this. Okay, because we have whole square here, that is what the problem is big. Okay, let us try to apply that here. Just a minute. Stream is clear, right? Hey, I exited the stream. Is it clear, right? Okay. Yes, Vicky, I'll just give me some time. I'll give you the exercise problem for type 1, type 2, type 3, type 4, type 5, right? See, it will be not tricky itself. It will be very easy only. Trickiest problem, I have solved all tricky problem, right? So instead of this, what I will do is, okay, let us draw a line. See, we will not use this. So we will go for some other method, right? So what we will do is, in finding PI, let us try to approach by this method. 1 by d square plus 1 whole square 24 x into cos x, right? Okay, so let us write this as 1 by so 1 by uh, so we have pi to be equal to 1 by d square plus 1 whole square 24 times x cos x, right? Okay, so this will be 24 1 by d square plus 1 whole square x into cos x. Now this will be 24 1 by d square plus 1 whole square x into, let's write this as real part of e power ix, right? Cos x plus I sin x. Now we have to replace d by d plus I e power x. So this will be 24 into real part of this term, right? Real part of so 24 into the real part of e power ix 1 divided by so d plus I whole square plus 1 whole square into x will be 24 real part of e power ix a plus b whole square a square plus 2ab plus b square I square plus 1 into x. These two will get cancelled, right? Because I square is minus 1, I square is minus 1. Just a minute. Just a minute. So you can continue from now on. Just a minute. I'm just looking for one message. Yes. So start is 24 e power I real part of e power ix. So this will be 24 so real part of e power ix 1 divided by, let's take this 2id outside. So let's take this 2id outside. So d square, sorry, 1 plus 1 plus d square by 2id, and here we have x will be 24 times real part of e power ix 1 by 2i into 1 by d will be 1 plus d square by 2id whole power minus 1 into x will be 24 real part of e power ix 1 by 2i 1 by d. This dd will get cancelled, so 1 minus x plus x square and so on up to x. Since we have x here, we don't even need d square term, right? So this will be 24 times real part of e power ix into 1 by 2i 1 by d. So d of x is 1, x minus 1 by 2i, right? So d of 1 into x minus 1 by 2 of d of x is 1. Okay. So this will be 24 real part of e power ix 1 by 2i. Derivative of 1 by d means integrate. So x square by 2 minus x by 2i, right? So integrate this term. So x square by 2 minus x by 2i. Now multiply this 1 by 2i inside. So real part of e power ix, x square by 4i minus x by 4i square, right? 4i square will be 24 times real part of e power ix, x square by 4i plus x by 4, right? Because I square is minus 1. So this will be 24 times real part of, now what is e power ix? Cos x plus I sin x. And here we have x square by 4i plus x by 4. Now consider only real part. Now consider only real part. What you will have? So consider only real part. Cos x into this term is real. So we will have x into cos x by 4. See any mistake you have made? But write whole square. See here we have whole square, right? One asset. Yes. Just now I have seen. Okay. So we'll write whole square here. So in that case, we will have d square plus 2id whole square. Everything will be missed. So we have whole square here, right? That means I can take this 2id whole square outside. This will be whole square, right? 2id whole square outside. So we have this term. This will be 24 real part of e power ix. This will be 1 by 4 I square d square. So this dd will get cancelled. So we have 1 plus d by 2y whole power minus 2 into x. So what is 1 plus x whole power minus 2? So it will be 1 minus 2x plus 3x square and so on, right? So we will consider only this term, 1 minus 2x term. So we will have this term to be equal to 24 real part of e power ix will be minus 4 and this will be 1 by d square of, so 1 minus 2x plus 3x square and so on, but I don't want to consider the term d by 2y whole square and so on into x, right? So this will be so 424. This will be minus 6 real part of e power ix 1 by d square, and here we have x minus here we have x, and here we have 2 will get cancelled. D of x is 1, so we have 1 by I, right? We have 1 by I, and this term will be 0 because d square r is 0. So we have minus 1 by 6 real part of e power ix. So 1 by d square means you have to integrate twice. So 1 by d of x square by 2 minus x by I, and this will be minus 6 times real part of e power ix x cube by 6 minus x square by 2y, right? We have to integrate this twice. Now we have to consider the real part, right? We have to consider the real part. Let us take this multiply by minus, multiply by minus. So we will have this to be minus 6 times real part of e power ix x cube by 6 plus I times x square by 2. Because this will be minus 2, minus minus will be plus, right? You always don't keep I in the denominator. Now this will be minus 6 times real part of, this will be cos x plus I sin x. And here we have x cube by 6 minus I times x square by 2. Now what is the real part you will have? What is the real part you will have? Cos x into this term will be real part, right? And yeah, minus 6 to be, right? And this into this is real part, right? So minus 6, so we have x cube by 6 cos x, right? X cube by 6 cos x. And here we have I into I is I square, which is minus 1. So minus x square by 2, right? Therefore, this will be, if I multiply this minus inside, minus x cube cos x, 2 1s are 2 3s are. So plus 3, here we have sin x also. These are the real parts, right? So I square is minus 1, so minus x square by 2 s. So if I multiply this minus inside, minus x cube, this will be plus 3x square sin x, right? Therefore, 3x square sin x minus x cube cos x is your required particular integral, right? So this method seems to be very easy, right? So rather than applying formula twice, I'm just writing this cos x as e power ix, and then I'm doing all the necessary things. So 3x square sin x minus x cube cos x is your required pi. But we still not finished with the problem. We need to find the constants also using this, right? We need to find the constant also using this. So therefore, this pi is not needed. So if you want to apply this pi, means you have to apply formula twice, right? Which in this case you can do, if you have free time, you just try to find pi using by applying a formula twice, right? You will get the same answer only, but it will take time. But this method seems to be very easy, right? So therefore, the general solution is y is equal to cf plus pi. So cf is c1 plus c2x, c1 plus c2x cos x plus c3 plus c4x sin x c3 plus c4x sin x plus plus pi. So pi is 3x square sin x minus x cube cos x, right? This is your solution now. Now you need to find y1, c1, c2, c3, c4. That is very easy part. You can do this. So to find c1, c2, c3, c4, I'll give you exercise, right? Very simple. They are given the 4 initial condition. What are the initial conditions are? When x is 0, these 4 are happening. So when x is 0, y is also 0. When x is 0, y is 0. This is the first initial condition. So substitute here, when x is 0, y is 0. So therefore 0 is equal to, when x is 0, this will be cos 0 is 1. So 1 into c1. c2 is x is 0. So c1 cos x. So which will be a c1 here. When x is 0, sin 0, everything is 0. This will be 0, this will be 0. So therefore c1 is 0. Right? And what is second condition? When x is 0, dy is also 0. So when x is 0, dy by dx is 0. right? You differentiate this term and find IC and find C1, C2, C3, C4, and you'll get something to be. And when x is 0, d square by dx square is also 0, right? And when x is 0, you will have, sorry, actually question is d cube y by dx cube is 12. Sorry, it's not 0, this is 12 when x is 0. So therefore, this will be 12, right? So find the dy by dx, d square by dx square, d cube by dx square, and all use this all initial condition. So if you use this initial condition, you will get the values of, you will get C3 to be equal to minus C2, right? If you get this, if you use this, you will get this condition. If you use this, you will get C3 to be equal to 0. C1 is 0, C3 is equal to minus C2. Okay, you will get C4 to be equal to 0 here. Here you will get C2 to be equal to 0. So if C2 is 0, C3 is also 0. So therefore, your C1, C2, C3, C4, all values will be 0 after using these initial conditions. Therefore, the solution is, to take this exercise, right, all are very easy. Solution is, this will be 0. All these 4 terms will be 0 now. So you will have 3x square sin x minus x cube cos x. This is your required solution, right? I'm just giving the exercise very simple. Just after initial condition, I also given the int also. I given the answer also. What you're going to do? What you're going to get? So is it clear? You can do the problem in this method also, right? Okay. So let us go back to the very first video that we have seen. So this is the very first video in ODE. So the syllabus, in the very first video, we have started with equations of first order and first degree integrating factor. Now we have completed this topic, second and higher order linear differential, and this, right? We have completed this topic. Equations of first order but not of first degree, that we will complete after finishing this method, right? So next class, we're going to start second order linear equation with variable coefficient. That is, here in linear differential equation that just now we have solved, you can say coefficients are constants, right? So a naught, a1, and so on up to an. If those are variable, that will be the next type. That will be the next method that we're going to do, right? This topic is completed. That is second order, second and higher order linear differential equation with constant coefficient. Now we're going to solve variable coefficient in the upcoming classes, right? That will be the third topic. After finishing that, we will have variation of parameters. So there are only 5 topics here. First one is formation of differential equation. Second is the one that you have completed. Third is the one that you have completed again. And we will complete this part. Variation of parameters is still left after completing this part. And then at last, we'll come back to this equations of first order but not of first degree. Right? The next class, we will be starting this second order with a variable coefficient. Right? This is what we're going to do in the next class. This is what we're going to do in the next class. We will be taking another 2 to 3 classes for this topic. After that, we will be solving variation of parameters. After completing variation of parameters, we will be solving these equations of first order but not of first degree. This topic, right? So we are left with 1, 2, 3. This topic I already completed. I'll give us a recorded video, right? So 1, 2, 3. So till 3 topics are pending, that will be completed in the upcoming classes in ODE, right? This is Laplace transform. Don't as of now we don't come to this. Just now we will concentrate on this part. So we have 1, 2, 3. So we have 3 topics still left, right? Actually overall 1, 2, 3, 4, 5, 6 topics only. 6 topics only there in ODE. We have completed 2. 1 is already completed as recorded format. We will complete the remaining 3 in the upcoming classes, right? So we'll just recall what is second and higher order linear differential equation constant coefficient. So we'll go back to the 13th lecture, which we have started, right? 13th only we have started. it's not 13, it's 14th. So in 14th we have started what is meant by linear differential equation. So we have started with this, right? Okay. So that's it. We just recall what we did here. So we have type 0, type 1, type 2, type 3, type 4. Laplace transform I already completed. You just go to playlist, you will get the video of Laplace transform. I'll be starting with inverse Laplace only after completing ODE, right? Laplace transform already completed. I'll be starting inverse Laplace transform only after finishing ODE. So we have type 0, type 1, type 2, type 3, type 4, type 5. So type 0 is RHS is 0. Type 1 is RHS is e power x. So you have to replace d by d plus a. Type 2 is sin ax or cos ax. Replace d square by minus of a square. And type 3 is polynomial in x. Use the formula 1 plus x whole power minus 1 or 1 minus x whole power minus 1. And type 4 is e power ax into v. So replace d by d plus a. Take the e power ax outside and you do type 2 or type 3 depending on the problem. And type 5 is x into v. So x into v is, you have the formula 1 by f of d x into v minus x into f dash of d. So orthogonal that actually comes under that only, right? That equations of higher order. See, this orthogonal theory comes under this equations of first order one of first degree, right? As of now, don't consider this. Okay. So type 1, type 2, type 3, type 4, type 5, x into v. So 1 by x into 1 by f of dv minus f dash of d by f of d whole square into v. Use that formula. If you have x into v, you can also write that as real part of e power ix, imaginary part of e power ix, if you have cos x or sin x, and so on. And the special case is x square into v. That is special case we have seen today. Is if you have x square into v, you write cos 2x as e power i2x, real part of e power i2x, and then proceed usual. Right? So that's it. I'll give you more exercise problems in these type 1, type 2, type 3, type 4, type 5, and so on in the Telegram group. Give me some days. The next class we will complete. We will be starting the next topic, which is second and higher order linear differential equation. The only thing is we will be having variable coefficient instead of constant coefficients. Right? There we don't have any types. We'll at least start starting problems. Right? Okay. So thank you. We'll see next class. No doubt. Right? If there is no doubt, we'll wind off. Yes, thank you. Thank you. Bye.